Hydrogen is one of the most common elements in our world. It's also the simplest, the smallest, and the lightest. Remember that simple H in the top corner of the periodic table of elements that we all saw in our high school chemistry class? Well, if you don't, you're not alone. Hydrogen is also one of the most misunderstood elements and a big part of why we're here today. Governments, organizations, and businesses around the world have committed billions of dollars and are racing to develop the technologies, regulations, and education required to help unlock the potential that hydrogen has in solving three of the fundamental challenges of modern society today: climate change, clean air, and energy independence.
We have an amazing hydrogen and fuel cell technology sector here in Canada. The companies and organizations working in the sector are investing about $200 million a year in research and development. That's about $1 billion in the last 5 years. We are importing wind technology. It's great, it's clean, it's available now, but keyword is importing. Hydrogen fuel cell technology we are developing here in Canada.
How can such a small element live up to such large expectations? The 5-year, 22-partner initiative called the BC Hydrogen Highways Integrated Waste Hydrogen Utilization Project is at the forefront of this race, and it's helping the world to see that hydrogen truly can live up to its promise of being the fuel of a sustainable future. The key benefit to hydrogen is it allows you to store energy in a tank, and then, very efficiently, use it to produce power without polluting the air, or adding greenhouse gases to the atmosphere that are leading to climate change. IWUP is demonstrating these benefits by using waste hydrogen to power trucks, buses, even a car wash.
The Integrated Waste Hydrogen Utilization Project, or IWUP as we like to call it, is the product of a lot of people coming together with some ideas to try and make productive use of a waste hydrogen stream. About 6 years ago, Sacre-Davey Engineering wanted to make use of a waste hydrogen stream that had been vented for over 40 years. This hydrogen stream has the ability to clean up the air around Vancouver and to be the model for waste hydrogen use in the world. The IWUP, as a platform to demonstrate those technologies, basically proved to be a phenomenally successful platform. IWUP really presents a model that shows an untapped hydrogen resource. There are thousands of waste hydrogen streams around the world. Using this model as a template, we can showcase how waste hydrogen plays a role in improving not only Vancouver's air, but the air quality and greenhouse gas emissions being emitted presently around the world.
Vehicles' clean air and climate change are certainly on the opposite sides of the fence without hydrogen. When you burn a gallon of gas in your car, you release 5 pounds of carbon into the air in the form of carbon dioxide and other pollutants. And since it's invisible, you don't see it. But what if it was a solid? Can you imagine every time someone burned a gallon of gas, they threw a bag of black coal out their car window?
Hydrogen as a fuel has the ability to reduce smog and greenhouse gas emissions in the vehicles that we drive. From this waste source, we have over 20,000 vehicles worth of hydrogen, assuming those vehicles run 20,000 kilometers per year. Can you imagine what a difference that would make to the air quality in Vancouver? This is a full-scale model that can be scaled up and deployed around the world. The fuel being generated from this plant will be used in IWUP's 4 transit buses, 8 100% hydrogen pickup trucks, and in an environmentally sustainable car wash that's going to be incorporating a fuel cell to power it and use the waste heat to wash the vehicles.
So if all this waste hydrogen is so available and provides so many benefits, perhaps the question should be, why not use hydrogen as a fuel? Hydrogen has been used in industry for decades. 95% of it comes from combining steam with natural gas. And it'll be some time before solar panels, wind turbines, or biofuel crops are used to produce hydrogen. IWUP is about achieving the sustainable future by providing a much-needed stepping stone: waste hydrogen.
Waste hydrogen refers to hydrogen produced as a byproduct from large petrochemical installations, electrochemical and steel mills. The plant here in North Vancouver, it produces equivalent to about 4,000 liters of gasoline per hour. You have to produce it cost effectively to be used in transportation applications. We truly believe that the HTEC plant here is one very economical way to introduce low-cost hydrogen into the economy. There are many sources in Canada today that are vented to atmosphere, and to put it in perspective, we need the equivalent of about 1,000 windmills, large-scale windmills, to produce the amount that we vent in Canada today. All the wasted hydrogen that's currently vented in Canada today would be equivalent to fueling 250,000 zero-emission vehicles. Waste hydrogen is a pretty good start to answer the question, where do we get our hydrogen fuel from?
In the future, most people will probably answer the question, where do we get hydrogen from, the same way we do with gasoline? The gas station, but not so fast. How does the station get it? One of the challenges with hydrogen is distributing the fuel from a central production site, like the HTEC waste hydrogen facility that we've seen.
Hydrogen is delivered to fueling stations via pipelines, as a liquid in big tankers, or as a compressed gas in tube trailers. There are a number of challenges in delivering hydrogen. Compressed hydrogen is the most likely route forward in the near term. We worked with Dynatech Industries, our partner in Calgary. We came up with a cylinder that was 40% lighter, held twice as much hydrogen as approved by Transport Canada. These cylinders are put into bulk packs called power cubes. There's a modular system that we use to distribute this hydrogen from the central source to the fueling stations. Very similar to the milkman principle of distributing milk, dropping off the full systems and picking up the empty ones.
Hydrogen has been used around the world for decades in a number of different applications, including everything from oil refining to computer chip manufacturing to even rocket fuel. But it's really only been in the last decade that hydrogen has started to gain acceptance as a fuel for transportation and power generation, as high-efficiency systems, like fuel cells, begin to move from space programs in the laboratory to products that are ready for commercialization. As a result of this acceptance and the province's existing hydrogen and fuel cell technology, British Columbia has formed the BC Hydrogen Highway. The BC Hydrogen Highway, including IWUP, represent the leading edge of the commercialization of hydrogen and fuel cell technology, giving everyday people and organizations the first-hand experience with the systems and transportation of the future. The Hydrogen Highway already has 5 Ford fuel cell vehicles and up to 20 fuel cell buses planned for 2010. IWUP is adding to this with their 4 hydrogen-powered transit buses and 8 hydrogen-powered trucks. The 8 IWUP hydrogen-powered trucks were converted by BC Hydro's PowerTech Labs in Surrey.
This is not your typical vehicle that most people associate with hydrogen-powered vehicles. It doesn't have your fuel cell. It has a good old-fashioned V8 with some modifications to keep the same kind of performance level as a gasoline engine. But essentially it has 0 emissions at the tailpipe. It's just steam. The hydrogen internal combustion engines, or hydrogen ICE as they're commonly called, are a much more cost-effective solution to fuel cell vehicles. And they kind of act as a stepping stone technology to help introduce the infrastructure necessary for a hydrogen industry. So companies with environmental interests are going to be acting as evaluators for these vehicles, and they're going to be driving them around for a 2-year program, putting approximately 20,000 kilometers on the trucks. PowerTech is going to be keeping track of the fuel usage and the emissions and engine performance throughout this program. So PowerTech, in conjunction with Sacre-Davey, has designed and constructed a refueling station, the majority of which is constructed off-site, and then the refueling station can be dropped onto a concrete pad. These cylinders are storing hydrogen gas at 5,000 psi and contained to this rear cargo bed area. There's a nozzle that's going to be on the station, and the nozzle connects with this receptacle, and the high-pressure gas flows into the fuel system.
Now let's go to TransLink's facility in Port Coquitlam to see another application demonstrated by IWUP. Buses powered by waste hydrogen.
We've converted 4 of the compressed natural gas buses to run on a blend of 80-20, 20% of it being a hydrogen mix. The biggest difference is going to be the cleaner burning emissions.
The reason it's really interesting to convert to HCNG these buses is that we can use hydrogen to power commercial vehicles with very little change in technology or modification, so using existing technology of today.
There's less nitrous oxides introduced out of the exhaust pipe, as well as much less greenhouse gases.
We can tune the engine to get lower emissions of air pollutants like nitrogen oxides, but also because the hydrogen here is a byproduct, we have a CO2 reductions because, of course, there's no carbon in the hydrogen. And so we have a net CO2 reduction between 7 and 10%.
There's virtually no performance changes whatsoever. After the testing, after the conversion to HCNG, the power and torque ratios remain the same, as well as the energy efficiency with regards to the running.
We filled some big water drums on board the bus to simulate some very patient passengers, and we subjected the bus to acceleration test, to hill climbing test, and we can maintain the original performance of the natural gas bus. The reason we feel this is really an exciting project is that this project really enables us to explore hydrogen in a very practical way and really try to go towards this goal of using hydrogen, which is such a great fuel, as a fuel in the future.
In North Vancouver, IWAP is integrating an industrial fuel cell into EasyWash's state-of-the-art car wash to provide both heat and electrical power.
Since day one, EasyWash had the goal of being the world's most eco-friendly car wash. And we started by looking at water consumption and, more importantly, water reduction as a way to really differentiate ourselves. So what we did was we drilled a 108-foot water well, and we treat it and filter it and use that to wash cars. A very basic calculation says that a car wash of our size will use about 24 million liters of water every year. Now, normally that'd be drinking water that you and I would consume on a daily basis. But instead, we use that groundwater and we save that very precious drinking water.
We use both electricity and hot water, and the fuel cell will provide us that. The secondary benefit is that our customers will get to see how the fuel cell works, so it'll be very exciting for our customers.
The fuel cell here at EasyWash is a 150 kilowatt combined heat and power fuel cell. We produce enough electricity to power the entire site. Additionally, when we produce that power, it also produces heat. We turn that heat into hot water and use that hot water to wash cars. When we're not using all the power that's being produced, we actually turn the switch and we send that power back to the BC Hydro power grid. This is actually one of the largest net metering projects in BC currently. Well, the fuel cell that's being used here at EasyWash is modular, it's space efficient, and they basically just drop it in with a crane. Now the great thing about that is it can also be used for many other applications, whether it be residential, industrial, and other commercial applications.
There's a lot that the IWAP is using hydrogen for, not to mention a few challenges.
My job and Sacre-Davey's role in this project is really to coordinate all the partners. We have 21 of them, and that's really what's needed to do a project like this, bring all the aspects together. You need government, not just government funding, but you need initiatives like the Hydrogen Highway that really pave the way on a regulatory side of things, as well as communications and education side of things. You need expertise, which in our case, luckily, most of it is Canadian, and you need early adopters, the ones with the patience to accept the new technologies and the testing that's been done in their systems. I think I speak for all the partners when I say that as things evolve in IWAP and more mileage is put on the vehicles and car wash uses clean energy, that their dreams will truly come true and all the years of effort will be well rewarded.
As you can see, hydrogen's being used for a number of different purposes. Even better, everyday people are using it. The future of hydrogen, a solution for climate change, clean air, and energy independence.
What the IWAP shows is that clean, green, renewable hydrogen can be harnessed and deployed in zero or near zero emission vehicles. This makes a real contribution to the reduction of greenhouse gases, which are obviously affecting global warming today.
With IWAP, the message we really want to portray with hydrogen is we can have clean air and we can have a sustainable future.
Global warming is such an important issue and really at the forefront of people's minds these days, and for a little car wash to be part of that and be part of the difference in what will hopefully be a world-changing technology is an amazing thing to be.
What the IWAP showcases is basically a made-in-Canada solution to the hydrogen and fuel cell economy. We have hydrogen fuel, we have applications, and we have the real ability to reduce greenhouse gas emissions. What the IWAP does is answer the chicken and egg paradigm that yes, you do need fuel and you do need applications. They both need to happen at the same time.
We have a unique situation where we don't have to solve all of the problems at once. We can get started. It's one of the reasons I'm really excited about this project.
The future of hydrogen, IWAP, bringing you the future of clean fuel today.